Have you heard? Soy's anti-cancer effects. So just how good is soy for you, and possibly your dog? An isoflavone found in soy, genistein, is effective in inhibiting many forms of cancer in people, including lymphoma. In fact, some studies have shown that eating soy-based products can lower the chances of developing some forms of cancer in people. A group of researchers from North Carolina State's College of Veterinary Medicine have started a series of studies to examine whether genistein might be helpful in preventing and fighting cancer in dogs as well. In the first study in this series, the researchers focused on canine high-grade B-cell lymphoma. This form of lymphoma is common in dogs, comprising up to 25% of all cancers in dogs. It is also similar to non-Hodgkin's lymphoma in people, so these studies are a good model for people as well. This first study looked at whether genistein could inhibit the growth of lymphoid cell lines in vitro. They chose two canine B-cell lymphoid cell lines, 1771 and GL1, which are similar to the human form of B-cell lymphoma, or non-Hodgkin's lymphoma. In people and cats, natural and synthetic genistein are not readily absorbed in the gut. A commercial mixture of soybean extract and mushroom mycelia culture called genistein-combined polysaccharide, or GCP, is much more readily absorbed. Both forms of genistein were used in the initial in vitro tests. The 1771 and GL1 lymphoid cell lines were exposed to increasing genistein and GCP concentrations and observed to see whether they were still viable for 72 hours. The researchers were trying to determine the half maximal inhibitory concentration, which is the concentration at which genistein or GCP inhibits the growth of half of the cell lines. In this study, genistein's half maximal inhibitory concentration for both cell lines was 10 micrograms per milliliter, and GCP's was 20 micrograms per milliliter. At this point, the researchers saw that GCP was more potent because a lower concentration of genistein in the GCP extract achieved the same effect as a higher concentration of pure genistein, so they used only GCP for the rest of their testing. With further testing, they determined that GCP's effect on both cell lines is apoptosis, or cell death, as opposed to cystostasis, or suppression of cell growth and multiplication. They used several tests to confirm that GCP was causing apoptosis. For example, they looked at whether the cell lines would uptake staining that indicated early and late apoptosis. They also determined whether caspase-9 and caspase-3 cysteine proteases were activated, which would indicate active apoptosis. A third test involved determining the ratio of pro-apoptotic versus anti-apoptotic protein concentrations in the cell lines. All the tests they performed confirmed apoptosis was indeed occurring. The results also revealed that the cell line 1771 undergoes apoptosis more slowly in response to GCP than the cell line GL1. Another aspect of this study was to determine how readily GCP is absorbed across enterocytes once administered to dogs. 3 healthy dogs were fed diets containing 0.45% GCP, and blood samples were obtained at several time intervals, spanning 20 minutes to 2 days after feeding. The samples underwent high-pressure liquid chromatography to determine how much genistein was present at the various time intervals. Complete blood counts and serum chemistry profiles were also performed before and then 2 days and 1 and 2 weeks after feeding to ensure no abnormalities were seen. These same dogs were later fed diets supplemented with 1% and then 1.45% GCP, with the same protocol for blood sample collection and analysis. The supplemented diet was well tolerated by the dogs. Up to 2 weeks after the feeding, none of the dogs exhibited signs of gastrointestinal toxicosis. None of the dosages of GCP given to the dogs reached the half maximal inhibitory concentration. However, even at the lowest dosage, GCP was detected in the plasma, indicating that GCP is bioavailable. The researchers also found that GCP was absorbed rapidly. The plasma concentration decreased significantly 2 hours after the GCP was administered and was absent 24 hours after. Thus, if this therapy is used in dogs, it will likely require frequent daily doses to ensure adequate concentrations are circulating to inhibit the cancer cell growth. The researchers concluded that genistein, especially in the form of GCP, appears to be promising in both preventing and treating B-cell lymphoma in dogs, since it induces apoptosis of the cancer cells. The next step for the researchers is to test the protocol in vivo, and the results may eventually be applicable to people with non-Hodgkin's lymphoma.